All right. So since no one showed up, I'm going to assume that everyone generally knows what's going on. So I'm not going to spend a lot of time making this video by myself, but I'm going to make this video and upload it and share it with everybody still. For the sake of when we get to exam time and people are reviewing, we have a video of these concepts in case people forget. So that's essentially that. So first, confidence intervals. They're fairly simple. Basically, you want to do the standard error type thing first, which is standard deviation over the square root of the sample size. And then you want to know what confidence amount you're using for that interval. It could be like 90%, 80%, 95%, 99%, or so on. Oh.
Hello.
Recording a thing already. I was just going to do it by myself, but if you have any questions, we could skip to that.
Okay, sorry, did I interrupt your flow?
No, not at all.
I have a question. I just started the homework.
That's no problem, yeah.
But I'm done with the first two questions.
Okay.
And I'm almost done with 3. Okay. I'm just trying to figure out how to get my answer because am I supposed to find the p-value? I have the t-value.
So you found this t-value, right? The observed one?
Yes.
So
5.771.
Yep. So when it comes to t observed values, you can do these t-tests similarly to how one survey or one statistic t-test would be done, where if you have a t observed value that you find and a t crit, which you would have gotten from that t table, and you compare them to one another, then you get some sort of result from that. Or alternatively, you could construct one of those like confidence intervals for the question itself, and then compare the difference of the means in that confidence interval. So
okay.
Here, I'll pull mine up and try to explain that a little bit.
All right. Also, how do I get t-crit again?
So t-crit, for example, so if we're looking at the number 3 in the homework, you know that the critical value is going to be the t-value, I believe, for degrees of freedom of 24, because the degrees of freedom is going to be that n1 plus n2 minus 2, because you have 2 different surveys, and then it gives you what was the question? Sorry, I didn't hear that.
How to get t-crit. I'm just blanking.
Oh yeah, okay. So t-crit, and then so basically the 2 surveys together at 26. You subtract 2 degrees of freedom to get to this 24 here.
Okay, that makes sense.
And then in the table, the one that's 2B in the appendix, you would go to 24 and then use the critical value for 0.01 and 2 tails.
Oh, so which table? Wait, I have the pictures of the tables on my phone. Wait, I'm using my phone. Sorry. um, okay, so I'd go to that table and then go to 24 and
Yep.
0.01.
Yep, in two tails. Make sure it's two tails and not one.
Okay. $2.797.
And I could check that really quickly. All right, 24 and 2.797. Yep, that's what I see too.
Sweet.
And that's what I have on my homework too. So then you would have whatever your T observed value was, and then this T crit value, and then you could compare those two, essentially.
Right, okay. So it's two tails because you're using
It's in two tails because in the question it asked specifically for difference.
okay. Sorry, I literally I just started, so I'm so not in the stats brain.
Yeah, no problem.
Thank you so much.
Yep. All right.
So my answer would be interpret the results. So there is a difference, right?
Yeah, so you're going to find that the T observed value was probably like pretty high. For me, I found that it was basically like bigger than 5, I believe. Wait, did I do this math right? I'm looking at it now and it looks wrong.
Oh, I also got bigger than a 5 though. 5.771.
Yeah, never mind. Yep. So it's like a number bigger than 5, and your crit value is that the 2.797 that you found.
Yeah.
And because your observed value is larger than the crit, you can conclude that there is, or you would reject a null and conclude that there's a significant difference because it's like in that critical region. So like,
right, because it's bigger than the
yeah.
critical value.
Yep. And to just like visualize that, it's like this was our graph. This would be the two critical regions here. These are like our 2.797 negative 2.797, and your point that you found is like way out here.
Yeah. Okay, that makes sense. Is there a specific way to word that or anything? Or is it just we reject the null in favor of the alternative?
Well, I would start by saying we reject the null, but like for the sake of being, I guess, like thorough, you could write out a sentence that explains like what conclusion the researchers would get to.
Okay.
So for the number 3, it's like, since they're asking if there is a difference in the amount of time babies pay attention to babies versus adults, then you would conclude that babies seem to significantly pay more attention to other babies than they do to adults.
That's interesting. Is that an accurate experiment? A real experiment that they did?
No clue.
I always wonder if these like examples are legit or not. Okay, thank you.
Yeah. And then when you do 4, it should basically have a lot of the same setup, but just pay attention since it's asking specifically of people who play violent video games act more aggressively. You want to do a one-tail test because it's questioning specifically for more.
Oh, that makes sense.
Mhm.
Okay, thank you.
Yep.
We can skip that then. I'll try to do that
Right.
on my own. Thank you.
And then besides that, the other section on the homework is R. Do you have any questions?
I have not really started that. I'm looking at my R right now. Yeah, I haven't started that at all. I could maybe pop out of the Zoom or just like sit here and try to work on it if you like wanted to continue whatever you were doing on the video. And if I have
Yeah, so
questions.
I mean in the video I was just gonna go over all of the equations quickly, but if do you have like when you were in lab, did you do the like examples, and do you have the example on your computer still? Because the example you can basically just copy, especially because the file for the example probably unintentionally is the same file for the homework.
Oh, really?
Yeah, it's the same set of data. So what we found in the example is actually what you're gonna find for the homework too.
Oh, okay. So is that all in the slides then, I'm guessing?
Yeah, so it's all in the slides, or if anything, if you're struggling later, you could always remessage and then I'll help again.
Yeah, okay. That's good to know. I'll try that. I'm sure it won't be too hard. I have not looked at the question yet. So I'll do that. But thank you for walking me through question 3.
Okay, yeah, no problem.
Yeah. Thank you so much for all of this again. All right. See you tomorrow, unless I have questions and I get really stuck or something.
Yep. Yeah, have a nice night.
All right. You too. Bye.
All right. So confidence interval, back to that. We were at this over this is equal to the standard error. And then I wrote out the percents earlier. I'm not going to write them all out again. And then you have some t-score. To be, and you just multiply these two together. So SE times, I didn't think that one through whatsoever, did I? Times the t-score is oh wait, let's rewrite this one more time. Okay, so you're gonna have your mean plus or minus the SE times the t-score. And that's how you make the critical or the confidence interval. I think everyone probably understands the non-directional and the directional choices here. So next we would have the new formula for the observed t-score, which is equal to the mean, or actually let's write mean like this, of 1 minus the mean of 2 over this s of x1 minus x2. So this is a difference of means over a standard deviation to get your t-score. It's similar to what we were doing in the past, just we have to calculate the numbers now. So this standard error or standard deviation that's used on the bottom is now alternatively solved by, here, I'll write it here. By a square root of, where's my mouse? Here's my mouse. Okay. So that standard deviation for the first graph squared over n1 plus 2 squared over n2. Or alternatively, there's a chance that you need to calculate this with that other formula, which is for when the two groups don't have the same value for n. So this is when the two groups do have the same value for n. When the two groups don't have the same value for n, it's still this, but this is now equal to the square root of SP over n1 plus SP over n2, and this SP is equal to the other equation, which is n1 minus 1 times the standard deviation of 1 squared plus n2 minus 1 times the standard deviation of 2 squared. And you have this whole thing here over n1 plus n2 minus 2, which you might recognize this as the degrees of freedom. And then these would be like the degrees of freedom for these individual ones. Just to kind of relate those ideas. And then when you figure out this number here, it just gets plugged in to those. And then the only other thing besides this was the fact that there's the way to also calculate confidence interval for a difference between two means, which is similarly, it's this minus this again, but now let's see, you just have plus or minus your t crit value times that standard error that you calculated before. Yeah, so I guess it wasn't that hard. It makes sense that no one showed up, and hopefully this is an okay recording.